In this video, we're going to explore how our blood glucose concentration is controlled by the hormones insulin and glucagon. And at the end, we'll see how these fit together in a negative feedback loop. Blood glucose concentration is just a fancy way of describing the amount of sugar in our bloodstream. We all need a decent amount of sugar in our blood so that our cells have a constant supply of glucose that they can use for respiration. However, if the blood glucose concentration gets too high, it can start to damage our tissues. So we need to keep a fine balance, where it's not too high or too low. If you were to eat a really big meal that had loads of carbohydrates in it, then those carbohydrates would be broken down in your intestines into lots of glucose molecules. These would then be absorbed into your bloodstream and cause your blood glucose concentration to increase. We can see this if we plot it on a graph that measures how blood glucose concentration changes with time. Before the meal, the level of glucose fluctuates slightly but stays around this normal level. Once we eat the carbohydrates though, we see this spike as the glucose is absorbed into the blood. This rise in glucose levels will be detected by your pancreas, which is an organ that sits just behind the stomach, and in response, it will release a hormone called insulin into your bloodstream. As it's travelling around the body, the insulin will bind to receptors on certain cells, which tells those cells to take in some of the glucose that's floating around in your blood. This happens in loads of different cells, but most important are liver and muscle cells. These two take up lots of the extra glucose molecules and combine them together to form glycogen, which is basically a long-term storage form of glucose. And so because all of this glucose is being removed from the blood glucose concentration is going to decrease. Looking back at our graph, we can see this as the glucose concentration falling back to the normal level. So we now know how our body fixes high levels of glucose, but we also need to be able to fix low levels of glucose. And this is where glucagon comes in. Don't get glucagon confused with glycogen. Glucagon is a hormone, whereas glycogen is a large molecule made up of lots of glucose molecules. Just like insulin, glucagon is also released from the pancreas, but it actually does the opposite of insulin, which is to say that it increases blood glucose rather than decreases it. So if we were to look at our graph again, and imagine that our blood glucose levels drop too low, for example because we skipped our breakfast and have been rushing about all morning, then our pancreas would detect this low concentration of blood glucose and secrete glucagon into the bloodstream. As the glucagon travels around the body, it would bind to lots of different cells, but mainly liver cells, which will take that glycogen that we mentioned earlier and break it down into lots of glucose molecules again. And then it would release these glucose molecules into the blood. This would bring the blood glucose concentration back up to normal, so that all of our cells have a good supply of it for respiration. If you think about insulin and glucagon together, you can see that they create a negative feedback loop. If glucose levels get too high, then insulin is released, which causes the glucose to drop down again. But if it drops too low, then glucagon is released, which causes the glucose levels to increase again. In reality, our bodies keep releasing insulin and glucagon to ensure that the amount of glucose in our bloodstream is always kept around the right levels. And this is why our blood glucose concentration constantly changes or fluctuates like this, rather than being a flat line. So we hope you found that useful. If you did, then please do give us a like, and we'll see you next time.